This last part, I want to emphasize this is only for 2 by 2 matrices. So for 2 by 2 matrices only, there's a formula which is preferable and faster to help us find inverses of matrices. So if you have some matrix A, which is AB in the first row, CD in the second row, then A is invertible if and only if, and paying attention to this, it says AD minus BC equals 0. I'm going to highlight a couple things. AD are diagonal from each other, minus BC, which are also diagonal from each other. And to calculate the inverse, so again, I'm going to emphasize one thing here. So the AD are diagonals of each other, the BC also diagonals of each other. So the equation we're going to use is A inverse is equal to AD minus BC, so that like that equation we just looked at a second ago, times the matrix D, negative B, negative C, and A. So again, the A and D in this case are flipping spaces. The C and D stay where they are, you just change their signs. Now that's a little goofy. So the denominator AD minus BC is called the determinant of the 2 by 2 matrix A. Essentially, it determines whether or not there is an inverse or not. So if AD minus BC equals 0, then you're not going to have an inverse of your 2 by 2 matrix. Sorry, just highlighting a couple more things here. If possible, find the inverse of each of these matrices below. If a matrix has no inverse, we call it singular. So what we're going to do on this matrix A here, we're going to follow the format. We're going to do, sorry, that's not what the writing tool I want. We're going to do A inverse equals, and we're going to focus on AD to start. I'm just going to use the same colors that I've been using. So AD is going to be 3 and negative 2. So it's going to be 1 over 3 times 2. There, it finally caught up. So 1 over 3 times 2 minus our BC. In this case, BC is negative 1 and negative 2. So we got negative 1 times negative 2. We'll clean that up in a second. Then we're going to multiply that whole fraction by the matrix, and we're going to swap the locations of A and D. So it used to be 3 in the A position and 2 in the D position. We're going to flip those locations. So again, those come from this diagonal. A and D, we're swapping their locations. We use those same numbers here. Now B and C, we don't change their locations, we just change their signs. So B used to be 1, now, or negative 1, now it's going to be positive 1. C used to be negative 2, now it's going to be positive 2. And again, just highlighting where that came from. You don't have to draw these highlights and whatnot. I just do it the first couple times just so you know where it's coming from. But we swap we swap the signs of B and C. Now right now this is a bit of a mess. So we have A inverse of 1 over our denominator here. We got 3 times 2, which is 6, minus negative 1 times negative 2, which is positive 2. So it's minus positive 2. So we have 6 minus 2 giving us 4 times the matrix we're currently at, 2, 1, 2, 3. So we're going to multiply each of those terms by 1/4. So 2 times 1/4 is 2/4 or 1/2. 1 times a fourth is just a fourth. And then second row, 2 times 1/4 is 2/4 or 1/2. And then the bottom right corner, 3 times a fourth is 3 over 4. I'm going to pause the video for a second, see if you can work on the last example on this page. First, determine if it has an inverse or not, and otherwise, or if it does, find its inverse. So I'm just going to start setting this up. We got B inverse of 1 over A times B, that's 3 times 2 again, minus our, A times D, which is 3 times 2, minus B times C, in this case B is negative 1, C is negative 6, and then we're going to write the matrix that we're using, or that we're going to multiply. Again, flip A and D, so flip the 3 and the 2, so we got a 2 there and a 3 there. And then change the signs of the other ones, so we got positive 6 and positive 1. Now, looking at this, we got 1 over, our fraction is, or our denominator is 3 times 2, which is 6. Then we have negative 1 times negative 6, sorry, that's a sloppy negative 6, which gives us positive 6. So it ends up being 6 minus 6, which is 0. Folks, that's a problem. and in fact, I told you to do it, and I didn't do it myself. The denominator of 0 doesn't work. So there is no inverse of this. So we're going to say B inverse dne does not exist, and therefore B is singular. And again, looking above to what we said earlier, that means it has no inverse. B inverse does not exist. B is singular.